Hi guys, today I'm going to be working through 4 more examples from exercise 3.4. So today we will do questions 5 to 8. If you haven't already seen the video for the first 4 questions, you can find a link to that here. Now look, they're getting a little bit harder now, so we really have to think really carefully. The sum of the first n whole numbers is equal, so before I even do anything, I'm going to say the sum of the first n whole numbers is equal to the sum of 2 parts. So there's going to be something plus something. So I'm letting S represent the sum of the first n whole numbers, and it's got to be equal to 2 parts, one of which varies as n and the other varies as n squared. Okay, so they want us to use K1 and K2 for our proportionality constants. So that means that we're going to have K1 times n, that is varies as n, and the other one varies as n squared, so that's going to be K2 n squared. All right, so I guess that we've done that now. So using K1 and K2, we have written down the expression for the sum of S in terms of n. So that will be part A. Now, by calculating the sum of the first 4 whole numbers and the sum of the first 5 whole numbers, find the values of K1 and K2. Okay, so what we can see in our formula at the moment, we have 2 variables that we need to solve. So K1 and K2, so that our formula will just have an S and an N in it. So they've given us some values, or they've given us some information how we can go about finding those values. So we're going to calculate the sum of the first 4 whole numbers. So 1 plus 2 plus 3 plus 4, so that equals 10. And that information means that the sum is 10 and that the number of whole numbers is 4. So that means we've got a point that we can sub in. So n is 4 and S is 10. So the next bit, we're going to do the first 5 whole numbers. So 1 plus 2 plus 3 plus 4 plus 5, well, that must equal 15. So that means that the sum is 15 and the number of whole numbers is 5. So our second point is 5, 15. And you know, now we can find the values of K1 and K2 because we can substitute them in. So I'm going to do that. So I might do it over here, K1n. So S equals K1n plus K2 squared, and that gives us 10 equals 4K1 plus 16K2. So that's our first equation, and again, you don't have to write the 1 next to it if you don't want, but it might be handy. The second, 15 equals K1 times 5 plus K2 times 5 squared, and that's 15 equals 5K1 plus 25K2. So this is our second equation, and well, now we can go about it by just, we can try and do simultaneous equations in order to solve for K1 and K2. Now, what I'm going to do here, I'm going to break these down a little bit. So I think I will divide this one by 2. So number 1, I'll divide by 2. So it'll give me 5 equals 2K1 plus 8K2. And the second one, I'll divide by 5. So 3 equals K plus 5K2. And keep in mind that you could do it on CAS now. So you could use your simultaneous button on CAS and you could solve like that. I'm going to do it by hand. Just it's good to get some extra practice with simultaneous. But realistically, this would be a CAS question. So you could do it on CAS. So now I have my green equation and I'll write the red one underneath. So remember, if you do the same on both sides of the equal sign, you're not actually changing the equation at all. And now I'm going to subtract those and a little 1 there. So that means I'm going to get 6 minus 5 is 1 equals 2k minus 2k, that will go. 10k minus 8k is 2k2. And that means that k2 is going to equal half. So that's our first value. Now we just need to find out the second value. So we want to find out what K1 equals. And I'm going to use this part of the equation. So 3, actually no, I might use the red one because then I'm going to get a whole number. If I sub K2 in as half and times it by 8, I'm going to get a whole number. So let's do that. 5 equals 2, actually K1, whoops, K1 plus 8, K2 is half. So that gives me 5 equals 2K2, 1 plus 4. And that means that I'm going to minus 4 on both sides. That gives me 1 equals 2K1. And, well, this means that K1 is also going to equal half, which is a little bit disappointing. It would have been nice if we had gotten a different value there. But both our K values, 1 and 2, are half. So let's go back and see what they want us to do now. So K1 equals half and K2 also equals half. So now we can say that our equation is represented by half. So the sum is going to be half n plus half n squared. And now, well, if the sum of the first n whole numbers is 1275, what's the value of n? So let's sub that in. Half n plus half n squared. Now, you can do this on CAS. If it wasn't on CAS, you would multiply everything by 2, which would end up giving us 2,550 equals n plus n squared. And we see we get a quadratic n squared plus n minus 2550 equals 0. And this is null factor law. Now, it's a CAS question, so what we can do is we can solve for n on CAS, and we get n equals negative 51 and n equals 50. And in the question, it's telling us it's the sum of the first n whole numbers. So we're talking about positive numbers here, so we can reject this one because it's negative, and we can say n equals 50. So the sum of the first 50 whole numbers is 2,000, no it's not, it's 1,275. Right, so that's that one. The next one is kind of similar. It's also pretty tricky. Given that y is the sum of 3 parts. One part is a constant, so I'm going to use C to represent the constant. Constant starts with C. One part is varying as x, and one part varying as x squared. So again, we should use these K1 and K2 values. So the first part, first varying part, it's varying as x. And then the second part varying as x squared. So K2x squared. So this will be our equation, and well, now we're going to have to find the values of K1 and K2. And they give us points here, which we can use to do that. So let's see, when y is 2, x is 0, so one point is 0, 2. The next point is 9, 1. Oops. And the third point is 2, 24. So now we can sub in those values and we get 3 simultaneous equations, which we'll be able to then use to work out the rule connecting x and y. So let's do that. This is particularly handy because our x value is going to be 0. You'll see in a minute. So 2 equals c plus k1, x is 0, plus k2, x is 0. So these are going to cancel out. So it means we're going to be left with c equals 2. And that's nice because now when we do this, we can just put the 2 in here instead of worrying about writing the c value. We already know what c is. So let's go to the next one, which is going to be in blue. So let's have 9 for y equals 2, because remember we already know that this value is 2, plus k1, and our x value is 1, plus k2, 1 squared. So this equation, we're going to get k1 plus k2 equals 7. So I've just minused that 2 on both sides. So that, I might call that equation 1. Let's go for the third point. So the third point, 2, 24. So that means y is 24. 2 plus k2 times 2 squared. And this will end up as 22. So I've minus 2 on both sides equals 2k1 plus 4k2. And actually I can divide this all by 2, remembering if you do the same thing on the left and right, you're not changing the equation, and that will give us k1 plus 2k2 equals 11. So now I have a second equation here, and I can use this quite nicely in order to do simultaneous now. So let's bring the first equation down. So k1 plus k2 equals 7. And, oops, it's equation 1. Anyway, I probably don't need those there now. I will now subtract them. So k1 minus k1, that will go 2k2 minus k2 is 1k2. 11 minus 7 equals 4. So our first piece of information is that k2 is 4. So I can now find k1 by just subbing that in. So I'm going to use this one here. And now that I know that k2 is 4, I can say k1 plus 4 equals 7. And then, well, k1 equals 3, so minusing 4 on both sides. So now I've got my values of k1, k2 and c. So I believe they're asking us for the rule. Yes, they are. I might just write it here. Actually, no, we'll probably need it. So y equals 2 plus k1x plus k2x squared. k1x plus k2x squared. So this would be our rule. And now we can use that in order to find any values we want of either x or y. I'm just going to move this one down so we've got a little bit more room. No, it doesn't want to. All right, so look, let's see what's next. Okay, so we want to find the positive value of x when y equals 117. So the positive value of x, so we might get 2 values, one of them may well be negative. So we want y to equal 117. So 2 plus 3x plus 4x squared equals 117. And look, this is a CAS question, 4x squared plus 3x minus 115 equals 0. So you can solve this on CAS, and what we get is that x equals neg 23 on 4 and x equals 5. And we can reject the negative because we are looking for the value of x that is positive. So that would be our final answer there for that, for that part. So let's just check, I think that's all of it. Yes. Right, let's move on. Question 7. We're going to do 2 more. So the cost of producing X 100 litres of olive oil is 20 plus 5x dollars. So I'm going to write cost equals 20 plus 5x. If the revenue from the sale of X 100 litres of the oil is 1.5x squared, so remember revenue, that refers to the money you get, not taking into account the money you spent. So again, the example I used in a previous video was if you sell cupcakes and you buy all the ingredients and then you sell them, and in your cash register you've got $100, then the revenue is $100. The profit is what you have once you've taken into account all the money you've paid for those ingredients. The revenue doesn't take that into account. So that's our revenue equation there. And it's telling us calculate to the nearest litre the number of litres that must be sold to make a profit of $800. So well, we need a profit equation, and profit is what you get, the money you have, the revenue, take away the cost, the amount you pay for like the ingredients or the labour or whatever it is. So now we can say profit, or P, is 1.5x squared minus the cost, which is 20 plus 5x. Now notice I put this in brackets because we need to subtract the whole thing. So the profit is not 1.5x squared minus 20 plus 5x. No, it's minus 5x because I need to minus this and I need to minus this. So that's why we have that as our equation. So we want a profit of $800. So 1.5x squared minus 20 minus 5x equals 800. And then again, we can solve this on CAS. So I'm just going to write it out more neatly first. Minus 5x minus 820 equals 0. And if you were solving it by hand, which, look, you probably wouldn't, it's a bit tricky to solve by hand, but if you were, you would put it so that everything is over on the left-hand side and it equals 0 because, you know, null factor law. So when we solve that on CAS, we're getting x equals 25.107 and x equals negative 21.773. And clearly, it's not going to be a negative cost or a negative number of litres. So we can get rid of that. And well, this is pretty much our answer. So this is x represents hundreds of litres. So it therefore makes sense. So x 100 litres. So then if we're going to find out the number of 100 litres, we're going to have to times this by 100. So it's going to be 2510.7, and they want it to, let's just double check, to the nearest litre. So if it's to the nearest litre, it's 2511. Their litres must be sold. So I think tricky there was where they're giving us the x 100 litres. So your answer can't be 25 litres. It's not, that's 25. Even 25 wouldn't be enough because we want to the nearest litre. But you have to make sure that you take into account that x represents 100. So there's x 100 litres, and that's 25.107 100 litres. So that's why we need to times it by 100 and then round it off there. Don't forget the units, and also it does ask us to the nearest litre, so that's why we're able to use decimals there. If it doesn't specifically ask, we don't use decimals. Last one for this video, we are going to do two consecutive even natural numbers. Okay, so for a start, the natural numbers are positive. So that's what that means. Two consecutive means one after the other, but this is consecutive even numbers. So if I give an example of two consecutive even numbers, I could say 2 and 4, or I could say 4 and 6. They're consecutive because 4 is the next even number after 2, and 6 is the next even number after 4, so those two would be consecutive. So to get from 2 to 4, I'm adding 2. So to get from 4 to 6, I'm adding 2. So if I call my first even natural number x, then that means to get to my next, or my consecutive even natural number, it's going to be adding 2, so it's x plus 2. So my two consecutive even natural numbers are x and x plus 2. And what we can see then, product means multiplication. So we've got x times x plus 2, and the product is 440. So x times x is x squared, and x times 2 is 2x, equals 440, and then I'll minus 440 on both sides. So I get x squared plus 2x minus 440. And if you're doing it on CAS, you don't need to make it equal 0. You can just solve it as it is. CAS will do that for you. But I just like to do that to remind you that if we were solving with cross multiplication, then we would, or with the quadratic formula, or complete the square, or whatever way you need to use, we would need to make it equal 0. In any case, the answers we get for x are going to be 20 and negative 22. And because it said our even natural numbers, we need to reject anything that's not even. Well, both of them are even, and we need to reject anything that's not a natural number. So it's just our positive. And what this tells us is our first number is 20, so that's 20. And then, well, the next one is x plus 2, or 20 plus 2. So the second number is going to be 22. So they would be the two numbers that we're referring to. And I believe that is all they're asking for. Yes, what are the numbers? So that completes the questions that I'm going to do for this video. I will do another video for the next 4, and I think then there'll be another one after that.